Hello and welcome to my session CI/CD for Serverless Applications. My name is Marcia Villalba and I'm a developer advocate for AWS. The talk today is going to be organized in the stages of the software release process. We all know them, but let's review them together. The first stage is the source. Maybe it's the last time developers see their code, when they put the code in the remote repositories. They will do pull requests, code reviews, and all these things. Now we have the build stage. We will be doing unit tests, linting, and getting our artifact that later will be deployed into multiple stages and the production. We are always deploying the same artifact into all our environments. In the testing stage, we are going to try integration tests, performance tests, security tests, all these tests that you need in order to make sure that application is ready to go to production. And when we go to production, we want to deploy with the least amount of downtime as possible. This talk will center all around choosing the right tools. I will present you a lot of different services from AWS that can help you out on getting your CI/CD for serverless applications totally automated. Let's start with the first one, that is AWS CodePipeline. CodePipeline is the orchestrator, is the tool that will guide our development process into other stages. It will take us from source to build to test to production. It's a service that will help us to visualize the deployment, and it's also help us to model the deployment using different stages and actions inside the different stages. It not only works with AWS products, it also works with third-party services. So this is an example of a production pipeline using CodePipeline. We can see here that we have 5 stages: source, where we are getting the code from GitHub; build, where we are using CodeBuild to produce the artifact; and 3 different environments: testing, staging, and production. All these environments are deploying using CloudFormation, the artifact we built with CodeBuild, into different environments. And also we are running different integration tests using Lambda or third-party services like RunScope. And even we have a stage where we can do manual QA and have a manual approval when it's completed. One good practice you need to have in mind is that it's good to put all these different environments in different AWS accounts. There are many reasons for that. I would like to emphasize 2 reasons. The first one is that if you're running any, load testing in staging, you have the soft limits and you will be sharing the staging soft limits with your production account. And that's very dangerous and it can put in risk your application. Another one is the security aspects. You might want to have different levels of security in the different accounts for your different environments. This is how CodePipeline looks like. We will have, in this example, 4 stages: source, build, stage, and production. And inside you will see the different actions. Again, we are getting the code from GitHub. We're using CodeBuild to build the artifact, and then we are using CloudFormation to deploy it and use Lambda to do integration tests. When we are ready, we will have a manual approval to deploy to production. So this is something great. You can visualize everything. In this pipeline, everything is green because the deployment went successful, but if there was any problem in any of these actions, it will mark it as red and you will be able to see the logs and analyze what happened. So, in order to release your software, there are many ways to do it. If you're building serverless applications, you might be interested in these 3 different ways. The first one, you can attach your code pipeline to a remote repository like CodeCommit or GitHub. So when something changed in a branch, then your release process will start. Or then you can use S3. So if you attach it to an object or a folder, and something changed there, then the release process will start. This is a great use case when you're using another type of remote repositories like Bitbucket or GitLab, and there is no support for that, and you can use S3 as an intermediate step. And now, because we support container images as Lambda images for your code, you can use Elastic Container Registry. So when the images change, then the build process will start. So let's start now with the first stage, that is the source. And in here, I want to talk about the infrastructure code and the code itself of your functions. Let's start with the infrastructure code. The infrastructure code, if you're familiar with AWS, you might know CloudFormation. That is our native way to do infrastructure as code. It's a common language where you can define all your infrastructure resources, and then it's a service that helps you to build and rebuild your infrastructure as it changes. So you don't need to run any manual actions or write any kind of scripts. If you're working with serverless applications, you can use AWS Serverless Application Model, or SAM. SAM builds kind of on top of CloudFormation, and it's an open source framework that helps you to build serverless applications, providing you a lot of shorthand syntaxes for expressing typical things from serverless applications, like functions, APIs, databases, event source mapping, step functions, and things like that that you need all the time when working with serverless. And then you can always extend it using any CloudFormation resource that is available. So how it looks something like this. This is a SAM template that produces a little architecture like this. This is a very powerful combo: API gateway, Lambda function, and then a table with the permission that the Lambda function has the capability to read on that table. We'll have all that defined in this little template. The first bit of the template tells CloudFormation that it's a SAM template and it needs to transform it. The second bit of the template is the definition of the Lambda function resource. And inside we will have the function configuration, where the code is, what is the runtime we are using. You can also add how much memory we want to allocate, the timeout, if it's a container image or it's a zip package. Then we have the permissions for the Lambda function. As you know, all resources in AWS are born without permissions, and we need to give permissions in order to allow them to do things. In this case, we want to allow this function to read on a table. For that, I'm using the policy templates. And the policy templates are predefined policies that you don't need to write, you just use them, and you can basically tune them to the right resource. In this case, we are using the read policy and passing the name of the table where we want to give the policy. I recommend you that if you are starting a Lambda function from scratch, you check the available policies to see if there is one that suits your need, instead of writing your own from scratch. And then we have the API gateway definition, and here I'm doing a little bit of a mixture. I'm defining the event trigger and the API gateway all together. But in the case that we will need to have the API gateway and reutilize it in multiple functions, we can define it outside of our function, and that will be fine. But in here, I just put it all together. And finally, we have the simple table, and this is using, again, a shorthand syntax from SAM to define a DynamoDB table with 5 read units and read and write unit capacities. But if you want to use a normal DynamoDB CloudFormation resource type, you are free to use it. One common scenario I have seen is that we want to build one artifact with the build process and then deploy it into multiple stages without changing it too much. And sometimes we might need to have, for example, this is a Dynamo table that will have different names depending on which stage we are deploying. That happens. Sometimes we don't want to rebuild the Dynamo table every time we are deploying, or we have an S3 bucket and the name depending on the stage we are deploying, or we have some, I don't know, URL or some parameter that we need to get from outside or from a different stack, that it changes according to the stage we are deploying. For that, we can modify our SAM template in order to be very flexible to the environment that is running in. So for that, the first thing we need to do is to define the parameters. And the parameters is basically all the names of your stages. In this case, I have 3, dev, staging, and prod, but if you have more, just list them here. And this parameter will be input by the code pipeline. So the code pipeline will tell in which parameter in which environment this needs to be deployed. Then we will use that parameter to pick the right name, in this case for a Dynamo table, but for every resource you need to have different names in different stages, and build this mapping table. So in that way, we will have a table with all the names for our DynamoDB table in all the different environments. And then we just use it. And for that, we are using the finding map information to find, according to the environment we get from CodePipeline, the right table name for the environment that we are deploying. So I mentioned that CodePipeline will pass this parameter into your SAM template, and that is happening with a parameter override. And I recommend you to read more documentation about it because it depends on how you define your code pipeline, if you're using CDK or you're using CloudFormation or you're defining it in the console. And you can find more information here. Also, you might want to have your code agnostic to the accounts or the naming of your, Dynamo tables again. So you might want to use environmental variables to pass information from your infrastructure to your code. And that's very simple. In your SAM template, inside your function definition, you will create an environmental variable where you are listing all the different information that you want to pass to your code. In this case, is again the table name. And then in your code, you just get that environmental variable. I'm using Node 12, so I'm using process.m, but different runtimes have different ways of getting environmental variables. Then, after I have the table name, I can use it anywhere in my code as it was defined there. Now let's move on to the function code. And the function code, before reInvent, it was very simple. It was a zip file. Now we have two options. We have the zip file that we all know and love, and container images that has been released just now. So if we want to use the function code as a container image, basically we can pack all the function code together and all its dependencies in a container image that is around 10 gigabytes as maximum. And then we can put it in the Elastic Container Repository and use it from there. This is great for organizations that are familiar with containers and they have process around containers and all their operations is based around it. So it's simplifying their way of using Lambda. But have in mind that these containers are still event-driven. So the Lambda function will be still triggered by an event. It's not running all the time. So if you want to get started with this, update your SAM to the latest version and then run SAM init. There you can get started with the SAM template and choose that one. And you can pick if you want to have a zip as your code or as image. And if you pick image, then you will be taken into picking what is the base image you want for this container. These are all the ones that are provided by AWS, but you can bring your own. And for that, I recommend you to read the documentation on Lambda supporting container images to know how to bring your own container image. But I will pick Node 12 because I'm a Node developer. And then my application is ready. What we'll see next, we will see a Docker config file in our SAM project. That's something new. It was not there before. And there, if we open the file, we will see that there is a base image. And that base image is the one that we just defined in the region that we are using. And then you will see the cmd command that is basically the location of our handler. The app, in this case, is the file or the module. And the Lambda handler is the method where this Lambda handler is. And then if we open our SAM template, we will see that there is a new attribute that is called package type image. So if we leave it empty, it will be considering that our Lambda function is using zips. But if we put image, it will say, okay, it's using a container image for its code. And then we need to provide the image URI, and that's the location of the image in the Elastic Container Repository. So now let's move to the build phase. The build phase will happen with CodeBuild. And CodeBuild is a service totally managed by AWS that helps you to compile and create these artifacts that later will be deployed into the different stages. The good thing of CodeBuild is that you don't need to wait in queue where all your organization is trying to deploy and build something. Everything scales horizontally and it can build multiple artifacts at the same time. There is no servers to manage and you only pay for the minutes that you use. When you get started with CodeBuild, you will get a basic container image that is empty and then you need to install all the things that are required. So if you're using CodeBuild with SAM, you need to create in the root directory of your SAM application a file called build spec. And in there, you need to write all the steps that CodeBuild needs to do in order to create this artifact. This is an example of one application. The first phase is divided in 4 phases. The first phase is the install phase, where we are going to install all the dependencies, all the packages we need in order to do the follow-up processes. So because it's a Docker image with nothing, I need to install AWS CLI, I need to install the SAM CLI, and I also need to install my application. Then the next step is to run my linting, my unit test, if I'm doing some CloudFormation test, all happen here. Then we have the build phase, and I'm using some build to build my application. And then we have the post build, where I'm building my artifact. This is using a zip code, so I'm getting the code from S3 and producing the artifact. And finally, I need to define my artifact, so then CodePipeline can use it later to deploy it in the different environments. If you're using container images, the only change that is needed is to change the SAM package, that instead of using S3, you are getting the code from the image repository. So that's the only change you need to do. So now let's move to the test phase. And this phase, I think, is one of the most important, and you can divide it in as many stages as you need. There's so many places that you can test when you're building serverless applications and modern applications in general. You can test in your source stage, where you are doing code requests, code reviews, or pull requests. You can test in your build when you are doing checking with the linter or running unit tests and making sure that everything builds and compiles successful. You can test in different environments, making sure that your application deploys successful, that you're doing integration tests against mock services or against production services, or running against third-party services like RunScope, or doing manual QA. Or then you can have even safe deployments, when you make sure that the deployment to production is very controlled and everything is monitored. So in this part, I cannot talk about everything because I only have 30 minutes. So I want to focus on 2 types of tests. First test is using Lambda functions as integration test. And the second test is making safe deployments. So let's start with Lambda functions to perform integration tests. So here we will define a normal Lambda function, as we are familiar, and we will use it as an action in our code pipeline. CodePipeline will be able to pass parameters to these Lambda functions in the event object that then you can use in your integration test. So you just write some integration test that verifies things you can get from your code pipeline, different parameters, different resource names, the environment you're running, and all that stuff. Then one important thing is that you let know code pipeline that the test passed or the test failed. If you don't do that, then code pipeline will be staying in a loop in that action and never getting out. So it's very important that you use the AWS SDK to let know code pipeline that everything is good or everything is bad. If things are bad, then this will stop and roll back to the beginning and the deployment will fail. And if this is good, then it will move forward to the next action or to the next stage. For more information on how to configure this, I recommend you to check the documentation, where you can find way more information and get some examples of this working. Now let's talk a little bit about safe deployments. And for that, I'm going to talk about a service called CodeDeploy. This is a service that helps you to automate your deployments. And it doesn't only work with Lambda, it works with containers, it works with EC2s, it works even on-prem. But I will focus now on the Lambda aspect. This will handle a lot of the complexity of deploying. It will handle all the downtime, so avoiding all the downtime. And in the case of Lambda, you will not have any downtime when you're deploying. It will handle also the rollbacks. So if something goes bad, then it will roll back to the previous version, and everything is totally automated for you. So safe deployments are deployments that are very controlled, and also that the previous, in this case, function is still available and can be rolled back very fast. So now imagine that you are deploying the version 2 of a function. Version 1 is working and is receiving 100% of the traffic, and you're deploying version 2. You will run some integration tests before allowing any traffic to that version 2. Then you will allow traffic. We have different mechanisms to allow traffic, and we'll cover that. And while you are allowing traffic, you are monitoring and making sure that nothing breaks. And then after you allow 100% of the traffic, you will run more integration tests. And then if everything goes well, then you're done. And then you can even delete version 1 if you don't need it, or it can stay there. But if anything goes wrong, then the traffic will go back to version 1 and roll back as if nothing happens. I mentioned that there were many different ways to allow traffic. When you're using CodeDeploy, you have 3 ways: all at once, linear, or canary. All at once is what it means, from 0 to 100% of the traffic allowed in 1 second. Linear, it means that you are going to increase 10% of the traffic every X amount of minutes, every 10 minutes, for example. So your deployment will take 100 minutes. That's quite long, but it's great if you're monitoring and making sure that everything is working. And then canary, it means that you are going to allow 10% of the traffic for, 30 minutes. You're monitoring that. And if everything goes wrong, then you are kind of allowing 90% of the traffic and you're done. So let's look at an example with canary. So you have version 1 deployed, that is receiving 100% of the traffic. Then you deploy version 2 and you run integration test against it. If nothing fails, then you are going to allow 10% of the traffic and monitor for any alarm. And then if everything is good, you move all the traffic to version 2 and then you run integration test against it. And then you're done. So how you do this with SAM is very simple. The first thing you need to do is to define an alias for your function. I just put live, you can put whatever you like. Then you need to say what is your deployment preference, linear, canary, or all at once. They are listed in the screen for you. Then you need to define the alarms that you are going to monitor during this deployment time, during this allowing of traffic. You can specify up to 10 alarms. And then you need to specify the pre-traffic hook and the post-traffic hooks, that there are 2 Lambda functions that will run as your integration test before and after you allow traffic. One common question I get a lot is, well, I would like to use this, but it's not very convenient to wait 100 minutes to deploy my code to production, to development. I like it to production, but I don't want to have 100 minutes of wait time for development. So yes, you can do that. You can have different strategies for different stages, and it's very simple. How you do it in your SAM template, you again use the parameters that you are getting from CodePipeline into the template. And instead of using mappings, now we define a condition. In this case, the condition, I call it isProd. That is checking if this is the production environment. And then I'm using that condition with an if clause. And basically, when choosing the deployment preference, I'm saying if it's prod, then use linear. If not, then use all at once. So now, whenever I'm deploying to anything else but prod, it's just going all at once, and my deployment is very fast. So now, we are in the production stage, but basically we already got to production. We have used CodeBuild to deploy from our testing into production with no downtime, making sure that our deployment is correct and is good. But here it doesn't end. We need to monitor and observe our applications in production, and for that we can use services like CloudWatch or X-Ray to have an end-to-end visibility of our application. I cannot go into the details of these 2 services, but I really recommend you to check this other talk, Becoming Proficient with Serverless Application Observability, where you will get the other half of this presentation, talking about the different technologies and techniques to observe your applications when they are in production. So to recap, today we have talked a lot about developer tools available in AWS. We have talked about modeling our infrastructure with CloudFormation and SAM. We have also talked about CodePipeline to define our release process using code commit, CodeBuild, CodeDeploy to go to production. We have mentioned lightly X-Ray and CloudWatch to monitor, and I have recommended you a talk to check out. I have not talked about Cloud9. That is a service that allows you to code your applications in the cloud. It's an IDE that is living in the cloud. So if you want to do, for example, local testing and you don't want to install everything in your computer, Cloud9 is great for working with SAM. It comes with a lot of tools integrated for that. So I totally recommend you check it out as well. If you want to get started with this, it's very simple. Go to the AWS Management Console inside the Lambda service and check the Create Application experience. You will create a serverless application that will create a SAM template for you, and also a CI/CD pipeline that is available for you to use, and then you can start working right away with CodePipeline and SAM. Thank you very much for listening to my session. Again, I'm Marcia Villalba. I'm super excited to talk to you today, and I would love to continue this communication over my Twitter, so please send me a message and tell me what you learned today and what you want to hear in the future. And check my YouTube channel where I have over 250 videos about serverless and the cloud. Have a great day and enjoy reinvent. Bye bye!